So I am Amit Mishra, as your teacher introduced you. We'll try to talk at a low level about robotics. I will try to give some familiar things that you might already know, like simple Newtonian mechanics, and then we'll slowly go towards Turing. I will try to finish the talk within 15 to 20 minutes so that we will also have another 10 minutes to discuss about any questions that you might have. Your sir already has introduced me, so there's a very quick introduction about myself. I come from Odisha, and I did my undergraduates in NIT Rourkela. Then I worked for a year in Bangalore and a year in Chandipur. And then I was doing my postgraduates and PhD in Edinburgh, following which I was an academic in IIT Guwahati. And then I have been an academic in the University of Cape Town since 2011. I worked in different kinds of topics and research areas, starting from radar to ultra-wideband to cognitive architecture. And of late, there has been a lot of work around application of artificial intelligence, machine learning, and what we call cognitive robotics. But that's enough about me. Let us discuss some interesting projects that I have got involved in, just to get you interested in what is feasible using technology. So that's a project that we worked on almost 2 years back, in which we used a drone, and I'm sure you all know about drones, to do a surveillance of a building. And in the surveillance of the building, we used an infrared camera. So an infrared camera looks at the infrared radiations. So those of you who have read a little bit of optics, you know, we have got rainbow color in the visible spectrum. And if you go in one direction, you bump into ultraviolet. In the other direction, you bump into infrared. Now, infrared radiation is also emitted by any hot bodies. So basically, the heat signature or the amount of hotness of an object is represented by how it looks in its infrared image. So infrared image captures the hotness of an object. Now imagine you are working in a building, let's say in your classroom, and let us say your classroom has got air conditioner. Now, if your classroom is properly sealed, like there is no leakage in the classroom, then all the heat that is also all the cool air that is generated, that stays in the classroom. Now, if there are leaks in the window, then the cool air will escape through that, and that will create more consumption of electricity. Now, if you take a picture of the building from outside, then you can see, okay, all these areas look cool, but you can see if there is a leak, you can see that, okay, certain parts of the window look hotter than the rest of the windows. That will imply that in certain classroom, there is some kind of heat leak. Then that classroom can be told, okay, you have to close your windows properly, or you have to repair your windows. So this is basically a quick way to check if all the parts of the buildings are proper, or there are some parts which might need some repair. So yeah, let me go to the next project. This project is also quite interesting, but again, this project I'll talk about is not my own effort. It's a very big team with researchers and scientists from many different areas. So there is a lot of study on the way weather patterns change in the northern pole, in Arctic Circle. But there is not a lot of good weather climatic models for southern hemisphere, that is Antarctic Circle. Why? Because of course there are more people staying in the northern hemisphere, in around the northern pole, than southern pole. But can we not apply the same models that we have developed in the northern pole, the southern pole? The answer is no, because the northern pole, if you think of your geography, that is water body, the Arctic Ocean surrounded by land masses, Canada, Europe, Russia, and all those things. But in the south, you have the Antarctica continent. That's a land mass surrounded by water bodies. So that is why the geography is different, the climate patterns are different. So there's a lot of differences between the north and the south pole. And that is why the climatic models used need to be changed. And how do you change a model? We'll talk about that a little bit later. To change or to generate any model, you need lots of measurements. So you have to measure what are the temperature, what are the pressure, how do the ice change there. So we have been working on developing a sensor platform which will be put into the big ice that float in the southern hemisphere. And then that will be there for a few months. It will be collecting a lot of data, and those data would be used to refine the climatic model for southern pole. Now, it's just an image showing the scale of the things. So now this is a container that is dropped from the ship, and in the container are some of our scientists and students, and that is the size of one of the ice where they put that sensor node, and that's how the sensor node looks like from far. So just to show them scale, like these things are very big, and these ice, because they look like pancake, they are called pancake ice. So that's also another work that I am involved in. Let me tell about some other quick work. So here are some things. I will try to see which one will be the easiest for you guys. Yeah, I think this one sounds easy enough. So, sometimes people need to be given injections, and the injections are of two types. One is intravenous, and another one is intramuscular. So in the intramuscular injection, that's like most of the common injections you guys get, that's intramuscular. So you can like prick anywhere in your arm or your leg. But the intramuscular injections, intravenous injections, first the nurse or the doctor has to find a vein and then inject the injection into the vein and then put the medicine into that. Now that is difficult because first of all, he or she has to find the vein. Now finding the vein is easy in adult human beings because the veins are more prominent. You might have seen that you can see the veins in the arms of your father or mother. But if you look at your friends, it will be difficult to see their veins because in children, the veins are a little bit hidden. Now, sometimes some children are born with certain congenital or from birth diseases or sicknesses for which they need to be given regular intravenous injections. And that creates a lot of problems. So most of the times the nurses will have to tap and find and prick the hand few times to get the right vein. So we wanted to make something very simple which might help to illuminate the veins. And we found that if you apply a little bit of heat around the arm, that helps in illuminating the vein. So we needed something that can put light into the arm. So any light would have done. But we also wanted something that will slightly heat the arm. Now, if you remember, just now we talked, heat means infrared, right? So we created an LED. You can see in the top side of the slide, a LED with a mixture of visible spectrum light, like simple light, and infrared light. So this one will both illuminate and slightly heat the arm. And you can see that the same arm in simple visible like ordinary light and with our LED, you can see that the veins are much more clearer there when we put using our light, because it also slightly heats the arm. Now, what else should I tell? Yeah, I think that let's just proceed. I can tell about this one. This is also the top right corner of the slide. That's an example of how machine learning and AI can be used in day-to-day life. So many times young mothers, they do not have the right kind of information when they're pregnant, and they might have some queries, and then they get a baby. Sometimes the baby might have some sickness, and the young mother doesn't know what to do with those things. So, and in the middle of the night, going to a doctor might not be easy as well. So we created a chatbot. It's almost like a WhatsApp messenger, but it is, the when you talk with that, the thing behind the screen is not another person, it's just a program. So this chatbot has been designed to talk to new mothers during pregnancy and after pregnancy as well. So any simple cases or simple queries the mother can have, this chatbot will be able to answer. Let us now move next. Now coming to the thing that we decided to talk about, what is a robot? I'm sure most of you have heard of a robot, and you might have also seen the robot in many movies. Now, if we think the word robot, that actually came not from scientists, but from literature people. So the Czech author Karel Čapek was the first author to use the word robot in one of his fictions, one of his plays. And he is actually attributed to be the father of the word robot, not the real robot. But that actually started the concept that, okay, something like that can be designed. Now, robots in the literature or in the creative world, it's imagined like a machine which looks like a human, which maybe walks and talks and does things like a human. So it's almost like a reflection of human that wanted to be created. Now, later, and those are the days in early 1900th century, and technology was not exactly mature to make a real robot. So it was mostly the literature artist people who were trying to give shape to the whole world and the domain of robotics. Then there came this author called Isaac Asimov, and in his books, lots of sci-fi books, he tried to formulate these 3 laws of robotics, which kind of stayed with us even after real robots were discovered and not discovered, invented and designed. We kind of still respect those 3 laws of robotics, which were designed by Asimov, who himself was not a robotics engineer. He was just an author, but he was quite futuristic in his visions. Right, and the laws, I'll leave it to you guys to read. So it's mostly like how the robot is expected to behave. So like mostly around ethics, like the robot should not be harming a human being. Like people from the beginning, they're a bit scared of these machines. If they start becoming more intelligent, they might start harming human beings. So these laws are mostly designed to make sure that the future robot systems should not be harming human beings. Right. Okay. Now let us discuss what is a robot. And the question, of course, comes, like, what is a human being? If you think we all are human beings, right? What exactly constitute a human being? So if you just think abstractly, we have our hands and legs, and we have got our eyes and nose, and we have the brain. We think about things, and then after thinking or after getting some, after seeing something or hearing something, we also react. So number one, we have got the sense organs, like we have got the eyes and the ear and the nose and the tongue and our skin. We sense things. In other words, we try to know what is going on around us. We sense to know about our immediate environment. And then we think, we process what we have sensed. And when we think, we use the current information, like what is happening in the environment, and we also use our past information. And past information can involve 2 kinds of information. Number one, the information you have collected over the time of your life. Like, for example, at some point in your life, you might have seen that, okay, if you touch a tea cup, then you get a burn. So then you learn that if there is a steaming thing in a cup, you should not touch it. So that is something you have learned yourself. But other things are something that you are born with. It's already embedded into your gene, like how to breathe. That you never learned that thing. You just know how to do it. You can control your breath, but the simple breathing that you are born with. So there are knowledge that you acquire over your lifetime, and there are knowledge that you get through genetics. Now, using those knowledge, you analyze what you are going to know or what you are knowing about the current state of the art in the environment, like what you sense. Depending on that, you then react. Reaction happens. You can blink your eyes, or you can walk, or you can do something, or you can slap somebody. So let's take an example. So let us say you have a friend whom you don't like, and let us say he has insulted you, or you had a big fight the other day. The next day, when you see that friend, you see the friend, that is through the eyes. That picture goes to your brain. Now your brain has got the incident that happened yesterday, that you had a big fight. Now, using that, the brain process. Now the brain decides that, okay, this guy is not a nice person. Then that gets reflected. Either you reflect on your face, that you look more serious, or you look angry, or you can also start shouting at this person. So you sense, you process, you react. These are the three things that kind of define human beings. There are other things like consciousness and soul, all those things. So let's not go there. Simplistically speaking, at a very basic level, these are the three things that defines a human being or any living animal. So your brain, you sense, you process, you react. Now, what are senses? Anything that you can sense with. And let's try to think what exactly does it mean when I say I can sense with. So inside our brain, we have got nerves. That is how we sense things. And these nerves, they work on electric signals. Similarly, in the robotics field, we sense, and when we sense, that creates these electric signals. And we sense means we sense things from outside. So outside, let us say the temperature or how things look like. And when you say look like, that's basically what kind of things they reflect in the optical spectrum. So a sensor basically converts the energy in one domain to electrical domain. So let us say it's a heat. We are measuring the temperature. So that's the energy is in the heat domain, and then it converts to electric signals. Or let us say you are looking at something, you are optical domain. So then the optical signals are converted into electrical signals. Same goes with your sound. You have got the pressure waves, because sound travels by pressure waves, right, in the atmosphere. So the pressure waves come, and those pressure waves through sensors, basically our microphone, are converted into electrical signals. So all these different physical senses or with different physical things, they are captured into electrical signals. That is the work of sensors. Any sensor you see, they have been designed to capture different types of other energy into electrical energy. Right? So that is the definition of sensor. A sensor is a device which can convert the information in one form of energy to electrical energy. Once in electrical energy, they are just currents or voltages. Now, next thing is actuator. So like how you react. So let's say in terms of reaction, we just talk, your face can change, you may look angry. Those things are controlled by your face or facial muscles. So the muscle changes. Or you can also walk away, you can run, you can try to start a fight. That involves your arms and your legs. So basically, the actuation or how you react mostly involves mechanical energy. It can, of course, also involve things like you talk. So, but talking also requires mechanical energy. You have to move your mouth, you have to move your tongue, you have to move the diaphragm so that you push out the right kind of air to create the words. And this involves a lot of Newtonian mechanics. So if you know, I'm assuming that you have read the 3 laws of motion by Newton, the first law, the second law, and third law. Those 3 laws are enough to enable you to design any kind of actuator. You can design any kind of motor, you can design any kind of pulleys and all those things. So actuator needs some way to distribute the energy and some way to give energy. So you need an energy source. It can be electrical energy, it can be thermal energy, anything like that. But you need to distribute it in a right way so that you achieve the right kind of action, right? Because if you think, when you decide to walk, how do you walk? You put your leg in certain ways, and then you bend your knees and your hip, and then you walk. So any action is basically a well-planned set of actions, right? So that is actuator, or like how you react. Now comes to the last part, the in-between part, the processor. So that's your brain, right? And if you think in physical world, your computer has got a processor, your phones have got a processor, and almost every modern device have got processor in them now. What do? They get the information. Now you remember the information are basically other signals converted to electric signals. So they get the electric signals in terms of currents and voltages. Then they do calculations on them. They can extract features, they can add, subtract, multiply, integrate, differentiate, and all those things. So what exactly it means by extraction of features? Now you are looking at me, right, through the video. Can you tell if I'm alive or dead? I'm sure you all agree that I'm alive, right? Now think, how do you come to the conclusion that I'm alive from this video that you are seeing? So you are seeing a video. What do you think? Why do you think that the thing in the video is alive? How do you distinguish that it's not dead? So you think just basic ways. Okay, you see that as a face, number one. You detect a human face. That's number one. And then you see that my face is moving. I'm creating some sound. And that sound actually sounds like a real word. It's not just gibberish. And then I'm moving my hand. So a human face plus sound, that is words or some kind of voice, and some movement. Those things kind of basically imply the thing you see on the video is alive. So these are called the features. So features are things that you find from the image or video or the sound, based on which you take a decision. So you look at the video. From the video, you extracted 3 things. You see a face. That's one information. Secondly, it's talking something sensible. And thirdly, it's moving the hands. So these 3 things are now features for you. Based on that, you conclude that this is a live person, it's a living person. Similarly, all this brain or any of the processor, they all work in a similar way. You have got signals from the sensors about the environment. You have got information from the previous experiences. We have talked about that. Based on that, you take some decisions. And just now we discussed that you have to take step by step. So any process or any thought process that you can program like that, step by step, is basically something that can be implemented on a processor. And that brings us to the next thing called Turing machine. So Alan Turing was the father of computer science, in some ways, and also the father of artificial intelligence. Now, some of you might have watched the movie Imitation Game, but that's about his life. Now, Turing gave the concept of Turing machine. So that is the definition of a computer So most computers you see, actually all computers you see now are Turing machines. What does it mean? If you can decide a step-by-step way to do certain thing, that can be implemented in a machine, and that is computer. So a Turing machine is a computer or a machine that can implement any step-by-step process. And it might sound a bit simple, but it's actually very fundamental. So if you can make a process for any action, that can then be implemented by a computer. So now that's a very fundamental thing. People think that consciousness and then emotions and psychology, those things are something very foreign. But again, think, if you can make a step-by-step process of your emotions, then that also can be implemented into a computer. That brings us to the next thing called artificial intelligence. So many things that we thought are like given by nature or God and very human. Now, if you think, at some point, some of the things can actually be translated into the step-by-step process. The moment it can be a step-by-step process, you can implement into a computer. So computer can have a lot of human-like smartness, and that is what is called artificial intelligence. And again, because Turing was the person to give this model, he also gave this model of artificial intelligence. He designed a test. How do you know that a thing or a machine is artificial intelligent? Now he designed something called Turing test. Now what is Turing test? In Turing test, is this Turing sword. So you put a veil or a cotton, and behind the cotton, that can be a machine or a human being. And you are talking to the cotton. You don't see what is behind. If you can talk with that thing and you cannot distinguish whether it is a human being or machine, then that machine is artificially intelligent. So far, none of the machines have actually passed the Turing test universally. So we still do not have a universally accepted Turing intelligent machine, but there are intelligent machines which have passed in different domains. Like if you decide that you only talk about medical science, then we have got computers. You can't distinguish if you are talking to a computer or a human being. Okay, my talk will end here. Because my time is ending, I will stop it and I will start the Zoom session again. Okay, and then we can have some discussions.